More concerning Scotland geology, yesterday I uploaded a video concerning the crack in the middle of Scotland because that half of the northern part of Scotland was part of Laurentia, which is today's North America, and the lower half under that crack was part of the Baltic area of Europe. And now Scotland's ancient lava flows reveals Earth's magnetic field weakening every 200 million years, geologists say. The Earth's magnetic field is generated in the planet's core and contained within a region of space known as the magnetosphere by the action of the solar wind. But this field is largely that of a dipole. It has one north pole and one south pole, with periods of variation when the planet's field can undergo a decrease in strength. Earth's magnetic field, crucial for life on our planet, as it protects it from deadly solar radiation and cosmic radiation, weakens around every 200 million years. According to a new study, the results of which have been published in Proceedings of the National Academy of Sciences, Dr. Louise Hawkins and her colleagues at the University of Liverpool performed thermal and microwave examinations on the rock samples from ancient lava flows in Strathmore and Kinghorn in Scotland, and we know Scotland also has had a supervolcano there. Dr. Hawkins said, "Finally, the last piece of work from my PhD is out. If you were a fan of the Mesozoic dipole low, then let me introduce you to its older sibling, the mid-Paleozoic dipole low." Analysis of the valuable rock samples confirmed that Earth's magnetic field, which starts in the molten core of the planet and extends to the vacuum of space as well, registered a quarter of its current strength between 332 and 416 million years ago. The researchers have dubbed this mid-Paleozoic dipole low. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And again, this is the crack that we have in the middle of Scotland, as you can see very clearly here in the aerial photograph. And this took place up to about 66 million years ago. This is one of the beautiful highland images showing the volcanic activity, the ancient activity in the area of Scotland, which of course has a supervolcano not many people know about. Now, the Mesozoic dipole low, MPDL, another similar period of low magnetic fields around 120 million years ago, was identified by researchers 30 years ago, and these new findings feed into the theory dating back to 2012 that the geomagnetic field periodically weakens, approximately every 200 million years. In the previous study, the field data was from the last 300 million years. The molten iron and other materials in the outside core are what comprise Earth's magnetic field, and these create electromagnetic currents, the dynamo action, which offers life on all our planet, protection from solar radiation. However, over time, this unstable field changes and fluctuates in terms of strength and direction. So it's understandable, moments when the geomagnetic field strength is at its lowest, solar radiation and cosmic radiation shower its negative impacts, harming life on Earth. This was the case with the mass extinction of 50% of animals and plants at the Devonian Carboniferous boundary about 359 million years ago. At that time, there was a spike in radiation levels similar to those during the MPDL. Dr. Hawkins, the lead author of the research, says this data set complements other studies we've worked on over the last few years, alongside our colleagues in Moscow and Alberta, that fit between the ages of these two locations. Our findings also provide further support that a weak magnetic field is associated with pole reversals as well, while the field is generally strong during superchron, which is important as it has proved nearly impossible to improve the reversal record prior to 300 million years ago. Both the current findings and pending research could help explain further behavior of the Earth's geomagnetic field and how it would affect life on our planet in the years to come. And this is on Sputnik News by Svetlana Kimenko. Please leave your comments and thank you for your support.